Hello, this is Jason with BDI, and in this video I'm going to show you how to use the math function on sensors. So for this video I'm running STS-LIVE version 1.4. I've got two nodes checked in right now. I've got a 16-channel terminal node and a 4-channel IntelliDucer node, and each one just has one sensor plugged into it. For the 4-channel node I have a voltage sensor, and for the 16-channel node I've got a sensor named MySensor that I've just set up as a voltage sensor. Now what I have plugged into those sensors is a function generator. So just to show you what's coming out, I'm going to start a quick test. And we'll give it a second to run. And you can see that what's coming out of the function generator is a nice sine wave. So I'm going to stop this test. And what you'll notice is it's got no offsets, so it's a sine wave centered at 0 volts. I'm going to click back over to my hardware tab, and what I'm going to do is apply a little bit of math to each of those sine waves. So we're going to start out with something real easy. So for this voltage sensor, I'm going to click on the y equals f of x, and that pops up a window that lets me enter in a formula that I want to apply to this. So we'll start out by doing y equals x plus 1. So the nice thing about this pop-up window is it's actually a bit of a code editor. So as you type things in, it tells you whether or not it's a valid code. So if I add another plus there without adding something, it'll tell me I have a syntax error and what I need to do to fix it. So I'm just going to have y equals x plus 1 for now, and there's no warnings. So I'm going to hit the green check. And I also need to save that value by hitting the green save button at the top. So when I do it, it saves that to the information about this particular sensor. So whenever I load this back up, it'll save that setting in here. I'm also going to add, for my sensor, I'm going to do one. I'm going to have it be y equals x minus 1. Hit the green check, and again save that to the sensor. I'm going to go back to my plots tab and start a test. So as you can see, now I have the same sine wave, but I've offset the volt 73 by 1, so it's now centered around positive 1, and I've offset the my sensor by negative 1, so it's centered now around the negative 1. Now this was all done within STS-LIVE by adding the math function to it. I haven't changed anything on the output of that function generator. So now the math is being applied to the data as it comes in. So this allows you to do corrections for any sort of sensors, or if you need to apply any kind of math to a sensor to get it to output the values that you need. I'm going to stop this test. So if I open up the editor one more time, we can see that you can enter in a variety of functions, polynomial corrections to temperature compensation, nonlinear functions. So, you know, it's kind of fun to maybe enter in something that you know it's not going to like and see what it does. We'll do a y equals 1 over x. And save that. And now go back to the plots and see what it does when it gets the infinity there. So there it goes. As soon as it divides by 0, it makes a nice jump there. And looks like we're getting a nice heartbeat signal there from a EKG almost. We'll stop this test. And go back and let's get rid of that 1 over x. You can also edit directly from the line here. The only disadvantage of that is if you enter in a wrong code, it's not going to pop up anything and tell you that it's wrong. It just won't let you enter it in there. So it is a little bit nicer to use the pop-up when you want to enter code in. But you can enter it directly from this field. So I could type something like natural logarithm and save that and go back to plot. And see that it makes a nice interesting function. When it goes negative, it becomes not a number there, so it's not plotted. The data on that will actually be entered as not a number into your TDMS file. So one thing that I will say about the math function is that the math function is applied to the data that you see streaming in here. And it's also applied to the data as it's saved in the TDMS file. So similar to when you apply an offset or a calibration factor, the data that's saved in your TDMS file is not your raw data, but the data that has the function applied to it. And that's it for using the math function to apply to sensor data.